Welcome to the third week of Quantitative Methods, week 10 of the semester, and this week we're covering estimation and hypothesis testing, which are in chapter 6 and 7 of the textbook, and we'll just be this week learning about how to estimate the mean, the population mean of the data from sample data, and also how to test hypotheses on it. And particularly when we do estimation, we're interested in uncertainty associated with the estimates, because we just have a sample and anyway the data is random and uncertain. And next week we're going to go on to regression analysis. So the kind of things we're covering this week about uncertainty in the data, uncertainty in our estimate, and how to do hypothesis tests, we're going to do for much more general kind of hypotheses when we cover regression analysis. But this week we're just applying them to the mean in order to get started. So readings of chapter 6 and 7 of the textbook. Again, there's a lot of examples from poker, but in the lecture I will do different examples. And also on the website you'll see I've attached several different resources beyond the common data set we've been using in the lecture and tutorials, which are going to give some different examples than just the common data set. I guess I was getting a little bit bored of it, but I've attached some alternative data. So one is data on wood use in a couple of villages in India, and this is data that my former master's student Jack Gregory collected when he worked for an NGO in India, and they just did a sample of 100 households out of 2 villages that have 250 something households in total. So we'll look at that as a case study, and that might be quite similar to the kind of data a lot of people will be getting in environmental management area, field study. And then we'll also look at a data set from research I've done on citation analysis and ranking of academic journals, which is quite a different field, but it's good for looking at the uncertainty that exists in data sets and some broader implications about ranking things, whether they're universities or countries or whatever they might be. And there's also a final article that's linked on the Waddle site is by John Ioannidis, who is one of the most well-known people in the field of meta-analysis, which is the field of analysing existing studies and trying to find out what we can learn from a large number of existing studies in statistical studies. And his article's got the very provocative title, Why Most Published Research Findings Are False. And that's the final topic we'll be covering in the lecture and also in the tutorial, which is the problem that of testing lots of different hypotheses and just finding which ones seem to produce an interesting result, or what we call a statistically significant result. Should be explaining this week what that means, and just publishing those results and ignoring all the others, and that results in bias in what we think we know about whatever the field of interest is. That article's quite technical, not too technical, so by no means are required to read that, but it's just there for additional interest. It's an article that's been cited a huge amount, probably because he had such a great title for it. The material this week again is quite technical, and particularly I think for understanding what the t-distribution is and why we want to use it. And so I've added a video which claims to be a non-technical introduction to the t-distribution that I think might help. So that is also on the website just below this video from me. Looking at the tutorial, all the 4 different problems we cover in the tutorial all use the same command in Stata, the one sample mean comparison test. So from that perspective, it's quite easy, just do the same command on different things. But I've constructed a tutorial to cover the various different topics we'll be covering in the lecture and provide actual hands-on data examples of those topics. So hopefully that will be interesting. Give you more insight into the technical material I'll be covering in my lecture. Okay, thank you. I'll see you in the lecture or in the tutorial.